Hey class, you may have heard of Khan Academy. Well, this is Shram Academy. So I'm making a little video tutorial to walk you through how to set up a magic square or ratio. Magic square just sounds like more fun, to find the actual specimen size. All right, so we're looking at the length and the width of a paramecium, so our paramecium dimensions, and this is from the physical hard copy handout that I gave you, and we did some measuring. And so we found in the picture that the length of the paramecium was 46.0 millimeters, and we found that the width was 8.5 millimeters. And we can see that in the image here, which I've cropped. All right. Now again, there's some wiggle room for error, and obviously the fact that we're basing everything on 4.5 millimeters of the diameter of the field of view at 40x magnification, well, that 4500 maybe and probably is off by a bit, but for now we'll just maintain consensus, and that way our calculations are all based on the same mistake in the first place, and we all know that and can account for that. But ultimately our final answers are going to be pretty darn close to what it actually is. So we need to remember then that since we are at 400 magnification right here, we need to use 450 right there. Okay, and one mistake I see students make sometimes when they're doing the calculations, they'll actually divide by 400 instead of 450 in this. So be careful. You need to know these tables, or this magnification table. You have to have these four numbers memorized. All right, and be careful when you're looking at your specimen to remember what magnification you're actually at. In this case, obviously 400x, and we went through why we chose that in class. All right, so we did our measurements, and now we're going to compare our real length to the actual measurements we've done in the picture. All right, so I'm just going to write length down here. So when you're doing your calculations, you want to set up your magic square. So your target quantity is the length of the paramecium over the diameter of the field of view at 400x. All right, so it's important to actually put that 400x on this side of the formula. Now we can just go length of paramecium over diameter of field of view, and I just like to write the word pic for picture. So these are the lengths we've measured with our ruler. Okay, and we're going to sub those values in, and you can just get right to the final answer from that point. So obviously if we're measuring something else like a nerve or a lumen of an artery or the diameter of a red blood cell, we're not writing the word paramecium. And the diameter of the field of view is going to change. It's going to depend on the picture. So when you're doing your homework, I already made a mistake, you got to make sure that you're putting the right number with the correct units in. And I'm looking for the numbers and their units and precision, appropriate precision. In this case, we're talking about 46 millimeters, 46.0 millimeters, and that tells us that that mark ended like right at that tick mark. Okay, so we're going to be as accurate and precise as possible, as our devices will allow. 110.0 millimeters means that we are right at that 11 centimeter mark. All right, now I set that up when I built these images on purpose so that it would just click into place like that. That may not always be the case. Okay, length of paramecium. So it doesn't matter if you did your initial measurements in millimeters or centimeters, because they're going to cancel out, as we see in this formula. So 46 times 450 divided by 110 is 188. Okay, so it's around 200, which is reasonable given that little other app we looked at the other day that said it was 210. And we know that not all creatures of the same type are going to be the same size, but it's around 200 microns in length. Now let's check out the width of this one. Same setup, okay? So except different symbols. So width symbol is W, little w. And we're still talking about a paramecium. There you go. And we're still at the field of view at 400 magnification. So with the paramecium in the picture over the diameter of the field of view, and this is all of the picture that we're doing, and I just color coded it in purple for the heck of it. You can use whatever color you want or no color at all, but the colors just help me remember what to choose. Paramecium. Okay, and our diameter field of view at 400 is still 450 microns. And again, give or take, right? Whatever that actually is, which I do want to find out actually. 8.5 millimeters, so that's teeny tiny. So our final answer is going to be teeny tiny. And that just makes intuitive sense. All right, and again, if you kept this as a 0.85 and 11.00 centimeters, that's cool too, because the centimeters will cancel themselves out. So our width of our paramecium in this case, of this paramecium we can say, is going to be somewhere around, and that's what this little tilde there, that little squiggle above the equal sign just means it's somewhere around, well, let's go 8.5 times 450 divided by 110 is 35. I'm going to round it off, okay? And just always round your final answer off to the nearest micron. Don't go to decimals of microns, because we know that, that 5 of the 35 is still just an estimate, okay? So this is in your OneNote and for your reference, so that methodology will help you do those 4 calculations for homework. But keep in mind to use the chart and look at the magnifications of each picture because they're all different. All right, I hope this helps, and we'll see you on Monday.